Hey guys, Matt, IronTrap Garage, and we are back working on the Roadster Pickup project. Last video we were working on the pedals, and we got that all kind of mounted in place. We're going to be working on some of the brake line stuff off camera in the background, plumbing brakes, and that's something we've shown a bunch of times. So something I want to show in this video, we've shown it before in other videos, but figured it was another good refresher, and also is a big step with this truck, and that is shortening the torque tube and the drive shaft. This is something that is needed to be done anytime you are swapping from the original drivetrain in a Model A, or even if you're just putting a 39 style trans behind a banger, you need to change some of this. So what we need to do is shorten the drive shaft and the torque tube. We're going to show you guys how to do that. It's a little bit different with doing this versus doing like a drive shaft on a later engine and trans combo. This is something that you can kind of do at home if you have a little bit of skills with the welder, lathe, and you can kind of shorten your drive shaft torque tube yourself at home, and it works out pretty darn good. So let's get started. All right, so first things first, we'll show you guys how we have everything set up. So we have this Model A rear cross member still in this car with a Model T, modified Model T rear spring that I had in my stash that someone made that has a higher arch, actually lowers the car a little bit, and is spread out. Someone had actually made the spring to fit a later V8 rear. So that was something I had scored that is perfect for this. We're using, they're hard to see in here, but the old Yankee bolt-on spring hangers that allows you to just bolt the Model A spring right on. It has the pinion angle stuff all kind of set for what a Model A should be from stock, which is essentially close to zero. A Model A or a early Ford, because it has a torque tube, is actually pretty much set with the engine and trans like level, very, very close to zero, and the rear is about the same. So what I've done is the engine and trans is already bolted on with the old Yankee kit, which sets everything kind of perfect. So this is within, I don't know, like 0.3 quarter of a degree or something from being perfectly flat, which is good with everything we have going on. What I've done on this side is I got a jack set up under the front of the rear, and I have it jacked up so that I could check with my digital angle finder and get the rear it's basically set at the same position. Because we do not have a torque tube or radius rods hooked to this, they are a structural part of the suspension on these, and that will allow the rear to just flop around. So I have that set. So now what we're going to do is take a measurement from this flange, right where the torque tube ball connects on the trans, all the way back to the flange that is at the rear. There's like a star-shaped flange back there. It's hard to see. I'll show you on the drive shaft here, or torque tube here, right there, all the way up to this point here. So you can see I have this ball, a spare one, swivel point for this. So we could take this measurement from basically here where it sits on the trans to there, and we can calculate that. That's a known dimension, and then we can just measure off the trans back there and take that out of it, and it'll give us what we need to do for our torque tube, which is already way too long, as you can see. So Steve and I are going to get some measurements set up for that, and I can get this thing in the bandsaw and cut it in half. Alright, so I got the drive shaft cut, and I have it mounted up with the kind of ball and socket set up here. So the retainers, it's like a two-piece like retainer piece that goes around. The ball portion of the swivel is another piece that's bolted to the trans. Then the torque tube goes in with the socket, and then this piece here that's I'm pointing at here, the two-piece portion, it's bolted on, and that's all clamped in place. That way it kind of sets the torque tube where it has to go. It's like a fixed location point we can't change. So I have that all bolted up here. I have my torque tube section, the stub, basically I just cut back like however many inches, I don't remember now, but I just cut back from the radius rod mounting point right here. So we're going to keep that so that hopefully we can retain it. And then we cut the torque tube here, and we're back into where it's not tapered anymore. That's the most important part, is that we're not cutting into the tapered section, because it makes it hard to line everything up when you're welding it back together. So back here, it is the same diameter all the way back to the rear. So cut it there. So now what I can do is take a measurement from the face of our cut here back to the face of that star pattern of the flange on the rear. That will give us our dimension that we need to fill that space, and then we can take the remaining portion of the torque tube, measure that, cut it, and then everything should fit up good. And then whatever it is that we take out of that larger piece, that's what we're going to take out of the drive shaft. So I'm going to take a measurement here and make our next cut. $27 11/16. Alright, so I got the torque tube bolted up, the section that I cut right here. Got that all bolted in place. I have it a few bolts in here, and they're snugged up so that flange is tight on the flange on the rear, so that the torque tube is sitting true as it needs to sit. And then what you can see is here, I fitted up to the front half of the drive shaft, and it is a tight fit, as it should be. We want this to be a very tight fit. Not that it's an interference fit, but like, you know, it needs to be very hard to push this together, because you have to take the rear or the engine and trans forward, rear out or the engine and trans forward to pull a torque tube. So that's how we want it to be. So up at the top here, I used a jack, started jacking up, got it even, and as I jacked it up, you know, kept the top even. It's nice and tight. Now what I'm running into is, let me move my flashlight here, we are hitting with the torque tube just at this flange here that we cut in the front for the old Yankee conversion. It's just hitting right there. So to close that gap up, that just is telling me that the torque tube, the front and back half of the torque tube are not jacked up evenly or at the correct angle, so because it's hitting there. So that's where we're running into an issue. So what I can do is cut that out after we get the torque tube pulled out this time. And then it should be good for clearance when we go to put it back together. So I'm pretty happy with everything. It fit nice and snug like it should here. And again, if we had the room to jack up with that flange cut out, this should all be even there. So what I'm going to do, pull these pieces out. I'm going to get some angle iron so that we can clamp it all together and keep it true. I'm also going to sand and bevel and clean everything and get ready to weld the torque tube itself. Get that all welded up in one piece. All right, so got the torque tube all welded up. I did it in the last shots. You saw I had it clamped in a big piece of angle iron that kept it all true. I made sure that I lined up our a factory weld seam here. So by doing that, that makes sure that if we're utilizing the original radius rod mount there, that will make it so that it is sitting towards the bottom and is all lined up correctly and not crooked. So that is important. So that's why I took some of that white chalk there and made marks for myself just to remind myself, because oftentimes I forget and just start tack welding and then I gotta cut it. So anyways, this is welded up. What I did is I had this piece that we cut off and took a measurement on it, and it is 18 5/8 is what I took out of that torque tube to make it correct. Oh, now you show up. So 18 5/8 is what I took out of that. So what I did is I knocked off the sleeve here. So we're going to be reusing this sleeve. This is actually what we're going to weld to the end of the drive shaft. We'll show that in a little bit. So what we need to do is take this drive shaft and take the exact same amount off. So if you're using a drive shaft and a torque tube that are the same, that is the key. There is different lengths. So if you go to a swap meet and buy one torque tube and then buy one drive shaft, then they're not the same. If you use this method, it's going to be wrong. So I took these right off of the rear that's under the Roadster Pickup, so I know that they're the same. So I can take the exact same amount off this end. So I knock this. You have to drill. There's a rivet on the one side, so you have to drill, and then like I use a carbide bit, and just because it's actually like smushed down in there and flared, so you have to actually grind it all the way down into the bevel and then knock it out with a punch, so, or a drift. So I got that knocked out. We're going to be reusing this, so we're going to set that aside and we'll be using that in a little bit. So what we're going to do is take a measurement from this end all the way up, and that's the part we're going to lop off. We're going to keep this front section. Has the same splines, but the reason we want to be careful is this has the little groove for the circlip that holds the bearing in the front. It also holds like the speedo gear and all that stuff in place. So this is important. If you cut the wrong end, you're not going to have that circlip groove, which will cause a problem. So we're going to cut from the other end where the sleeve was on. So we're going to be taking 18 5/8 off of here. And then I took a measurement of the depth that this sleeve was sunken in here before I actually drilled the rivets out. So I have that noted over by the brake. So that's the amount that we're going to turn down on the lathe. I took a measurement of the inside of these splines here, and whatever that dimension is, the smallest dimension, is what we want to make this. We want to make this just about the same size or just a hair bigger, so that we can have an interference fit. So if you're not confused, you should be. So I'll show you guys here in a minute. I'm going to mark this, cut it here on my nice cold cut saw. This thing has been kicking ass. Evolution hooked us up with this a while ago, and I can't say enough good things about it. It's been great. So I'm going to use this to cut the drive shaft. It is solid, so we're going to have to go nice and slow. And then we will discard the piece we don't need and start throwing it up in the lathe. so we got the torque tube, drive shaft, everything all bolted up. It is not a small feat on any early Ford with a torque tube to get the rear torque tube drive shaft all started. You have to monkey around at the transmission, and while you're rolling the rear forward, the drive shaft is turning, and then you have to try and turn the U-joint on the transmission, get it all to line up and slide together, and it's kind of like a monkey in a football. It's never easy. But we got it in, like, I don't know, 3 or 4 tries. We got this to slide in. Just had to use a little pry bar to get the spring and the cross member to seat together. Everything popped together, and it worked out pretty good. Now, for anybody that's going to shout in the comments, this is kind of a mock-up. We're going to be pulling everything apart to paint the frame and all that type of stuff. So I didn't put any of the paper gaskets in because they would get wrecked taking them on and off. They're like a one-time use deal. So bolted everything up just to make sure everything worked and fit how we wanted, and it's pretty much good. Kind of off camera, I knocked a temporary pin into the drive shaft where it goes into the rear just so everything stayed, but we were getting a reproduction one that we could put in there and smash flat like stock, and should work out good. So now we have the drive shaft all in, and we have the engine and rear and trans and rear all connected. We technically could fire it up and move it around, which is very, very tempting. But we're going to work on some other stuff that we need to take care of. Probably the next thing is the windshield. We got a new bed for the truck, so we're going to be swapping that out here soon. And probably in between there, we're going to blow everything apart. And at the very least, paint the frame so that if we put it back down, we can keep working or even start test driving it this summer. And we don't have to worry about a bare metal frame that's going to rust over time. So huge step with the Roadster Pickup project. And we are getting close. This thing's going to go around the block here in the next few videos. I think we're going to be taking this thing around the block, and I cannot wait. It's going to be awesome. Thanks guys for following along. Catch you later.